Hello everyone, welcome to Zaref Game Dev. In this part, we are going to uh, the whole section is going to be generating our levels. We have created the whole game for playing our levels, but we need to generate the levels ourselves as there are going to be 50 levels per stage. And if you want, you can type the all levels 50 times. It's not much time. You'll need to spend some time, which should be rather small. And all the levels are available online. The flow free solutions provides us with all the levels. And if you don't want to learn it how you want, then you can directly copy the data from there. And almost supposing 50 levels will take almost like half an hour, then you can finish in like 2 to 3 hours. But learning would be good. And let's see what our game has been till now. So this is our first level, and everything's perfectly fine. There are not any issues, and our game is working perfectly fine. And we can also switch to the next level. So now what we want to do is inside our prefabs, we have our levels, we have our default level. We need to generate all of those levels, and we need to generate it through code, and we'll observe through couple of methods how it's going to work. And here we are going to have the main coding part. So creating the game was easy at there was just one node and we added method to access it. But generating the levels is going to be much more difficult because there are like endless combinations. And for 5 cross 5 grid there are, I think, 5 to the power 25, so you can imagine how big it is going to be. And what we need to do is find solutions and add those solutions. So we have our level generator folder opened up. First we are going to create our new scene, and we'll save the scene inside our level generator. And the scene name is going to be level generator. And inside our level generator scene, we'll create our level generator script and also our node renderer script. So a node renderer is similar to node, but we are not passing any operations here. We are procedurally generating the levels. So it should just show the points and the edges, and it is going to be perfectly similar to how our prefab was working. And we'll create and so this we are going to watch it inside the landscape mode. And let's set the background color to be our white color, and let's set up our UI. So our UI just has one image, which is our simulate button, and when we click simulate we should be able to simulate, and the sprite is going to be our square slice 16. And for the color we are going to use the dark color, and for the size let's use 768 minus 64 minus 64, so 512 by 128, and we'll position it from the bottom at 128. And we are going to add text to it, so let's add UI text, and this is just going to call the simulate. Let's position it to the center. Let's increase its size to 96. Stretch it across the whole screen. Let's decrease more size, and let's set its font to our SIMULATE. And the color, let's change it to yellow. So there is not much going around here, and we are going to have two more texts. And the first text is going to be our counter, which is again going to be 512 by 128, and let's change its text to some number. and let's align it to the center, and we'll position it from the right. And for the x we'll use -56, and for the y we'll use 128, and again it's going to be 64, and we'll use our font. So this is showing to show our counter how many steps has passed, and we'll duplicate this counter, position it from the left, and we'll make it positive 256. And this is going to be our solutions. So how many solutions did we find? So the right one is the counter, which is going to increase, and our simulation is going to run here. And the left one is going to show us the total number of solutions. So we need to see the amount of solutions, cause my PC is not too good, and almost every PC won't work perfectly fine, cause we are not going to use any optimization solutions for the beginning, and Unity's memory allocation and whatnot stuff, it's almost pretty complicated. So what we'll do is first create our basic setup, and after that we'll visualize it, and then we'll start optimizing from the different methods. And doing all of this is just to see how each of the methods work, and we are going to learn so many different things doing that. So that's why we are doing it, and we'll have it scale with screen size, and we'll use 1920 by 1080. And as you can see, this is going to be our generator, and our level generator is going to have a level generator script. And let's create an empty, I mean, we could just let's go inside our project and prefabs. Let's bring in the node, and let's remove the node script. And as you can see, this is just our default node, and we'll bring in so it is we don't need the highlight. Okay, so we cannot edit it. So what we need to do is bring inside our level generator, and we'll create as an original prefab. So this is our node, and this node is different. It is not connected to anything, and our node renderer should not have any issues. So for that, let's go inside our main menu, and let's see if our game is still working perfectly fine. So our node renderer didn't do anything, and that was our node. And here for the node, we don't need the box collider 2D, cause we are just going to have visualizations, and we are also not going to need the highlight. And what we are going to need is our node renderer script. And I think, yeah, the node renderer script will also need to copy it. So we'll add the node renderer script afterwards, but what we first need to do is set up our level generator. So let's open up our level generator, and let's hit reload. So it will bring in all of our assets, and let's go to Visual Studio. So this is our level generator and node renderer, and almost all the methods are easy. I'll need to open up my level generator script. So it should be inside the projects, puzzles, assets, and level generator. And let me open with Notepad, Control C, and I need to mm, 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 mm. So node renderer, and just wait around 30 seconds. I need to update inside my node renderer. So node renderer is going to be pretty simple. It's going to have an init function and a method to show all of our mm, edges. So depending on what direction will pass, it will show us the edge. And let's create our node renderer first. So first one is going to be private list of color and colors, and we can call this node colors. And after that we are going to have a private game object for the point and a private game object for our top edge and bottom, left and right. So we have all of our edges and our public void init function in which we are going to turn everything to false. So point dot set active to false and top edge dot set active to false, and everything is going to be turned false. And finally what we are going to have is our public void set edge, and here we are going to pass our color ID and a direction. So our direction, let's get our game object connected node is equals to point. So if we are passing any of the previous directions, which is the up, down, left or right, we'll set the connected node to true, and we'll get the component, which is our sprite renderer, and its color we will set our node colors and our color ID. And what happens when our direction changes? So we'll just change our connected node. So if direction is going to be up, that means we are going to pass the connected node to top edge. Then if our direction is going to be down, then connected node is going to be bottom edge. And if our direction is going to be left, then we are going to pass the left edge. This autocorrect is pretty good. So I think this feature just recently updated. So and if our direction is right, then our connected node is going to be the right edge. And instead of if, we can use an else if. So yeah, else if, and if our direction is 0, then our connected node was our point, which was the starting one, and it should show us our edges. So let's go inside Unity and let's set up our node. So this node is different, top edge, bottom edge, left edge, and the bottom edge and the right edge. And in the next part, we'll start changing our we'll start with a level generator, where first we'll first need to spawn both of our uh, board, the background cells and the nodes, and after that we'll in the next part we'll create our scriptable objects directly from our scripts. So we can directly create that from scripts, and that's it for this part. So we created our node render script in the previous part. Now we'll need to set up our level generator as we are not doing anything right now. So let's go and start scripting our level generator. And there's not going to be anything going on in our node renderer, so let's hide that, and let's create a region for our start methods, and let's end the region. And first we are going to have a serialized field for the private pool can generate once, and instead of, yeah, it is going to be serialized, then our serialized field private int for our stage. Yeah, and private integer for our level size because we are going to need to access it, and we can directly use a getter, uh, not even needed to use the getter. So our level size is always going to be our stage plus, so if we are in the first stage, then it is going to be 5. And after that, inside our awake method, we need to spawn our board and also spawn our nodes. And for spawning our board, let's create a serialized field, private, and sprite renderer. And for the first sprite we are going to need is our board prefab and our background cell prefab. And after that, we'll create a private void for spawning the boards. And inside our board spawning, what we'll do is we'll first instantiate our board prefab, and it is going to be instantiated at new vector 3 at quaternion.identity, and the value we are going to pass is level size divided by 2f, again level size divided by 2f, and 0f. So that's where we are going to instantiate, and our board is going to be board.size is going to be new vector level size plus 0.08f, and again level size plus 0.08f. So it will spawn our board, and after that we need to spawn our background prefabs, but let's first set our camera. So camera dot main dot uh, orthographic size is going to be equal to our level size, and it needs to be divided by 1.6f cause here our camera is wide. So instead of the vertical position, we are calculating the horizontal, and we'll add 1. And after that, we'll set its position. So camera.main.transform.position is going to be new vector 3, and here we'll pass level size divided by 2f. Don't forget to add 2f, or it will return an integer, and negative 10f, that's where our default camera is. And we are going to instantiate I less than our level size, and again j less than our level size. We are going to instantiate our background cells. So We don't need to do anything, we'll just directly instantiate. So instantiate background cell prefab at new vector 3, I plus 0.5, j plus 0.5f and 0f, and finally quaternion dot identity. So this should spawn our board, and next we need to spawn our nodes. So let's create a serialize field, and it is going to have a private node renderer, and this is going to be our node prefab. And inside our node prefab, we are going to create a function to spawn our nodes. And hmm. So we also need a dictionary. So private dictionary, which goes from, did I create it before? Yeah, v2int and to node render. So we can directly access the dictionary depending on the x and y we pass. And we'll call this node grid. And instead of private, we'll make it public. Maybe we'll need to use afterwards. And let's see how we are going to spawn. So the first thing we'll do is set the node grid to a new dictionary, and let's cache our spawn position, and we'll go from level size and again level size, and again we are going to set our spawn position to new vector 3, I plus 0.5f, j plus 0.5f and 0f, and we are going to instantiate our node. And let's create the memory before, so node renderer, and we'll call it spawn node. So if we create the variable inside, then whenever the loop repeats, it will get deleted. Just some minor optimization. It doesn't matter, but it is good to initialize outside of loops, so it doesn't reassign and create new memory. And our spawn node is going to instantiate our node prefab at our spawn position at quaternion.identity, and we'll initialize our spawn node, and we need to add our node grid, and here we'll pass our new vector int of I comma j and spawn node, and let's also set its name to be equal to I dot toString plus j dot toString. And after we have created both of these functions, we should be able to spawn our nodes. And let's go inside Unity and let's see if it is working. So currently we are going to spawn the 0th node, and we'll set the can generate once to true. And our prefabs, we are going to use our board which we have previously created, and our node is going to be from our level generator, which has the node render script attached. And now for the 0th level, it should show us a 4x4 grid. And as you can see, it has already generated all of our levels, and that's how our simulated grid is going to look. And in the next part, we'll start creating our scriptable objects from the scripts. And after that, we'll explore all the methods that we are going to use. And as I'm going to create the project along with the new methods, some of the methods may be wrong, and the goal is to learn new things and fail, and even if we fail, the point is to learn and try different new methods and see what we find. So let's see it in the next part. So we have generated an empty level, and what we now need to do is create our scriptable objects from the screens when we hit the simulate button. And let's go inside Visual Studio and let's see where we'll need to start. So we'll create a new region and let's hide this region. And rendering this region is going to be for rendering our node hashtag end region. And before that, we are going to have one more region for our button functions. And what we are going to do inside our button function is when we hit the button, we are going to generate the level. So let's create a serialized field and our private game object, and this is going to be our simulate button, and the function is going to be our click the simulate. And inside our click simulate, if our can generate once is true, then we are going to generate the levels, else we'll generate the level multiple times and we'll need to pass some parameters. And yeah, so let's see how we'll generate our level. Let's generate default level, and to generate the default level we'll need a private, and this is going to be our level list. And we are not able to get the level list cause it is inside different assembly, and let's delete for now, and we'll need to add the assembly reference and reload the scene. So let's go inside Unity, and our connect doesn't have any assembly references, so we are going to need two of them. So the first is going to be our connect.common, and the second one is going to be our text mesh pro. So unity.textmeshpro, cause we are going to show both of our okay, let's apply. You must exit play mode to save the scene, and we added both of these assembly references. Now we can go inside our Visual Studio and we can get the mm, let's so serialized field private level data, and it is not going to be level data, it is going to be level list, and our level list is going to be our all level list, and we'll convert this to a dictionary which goes from string to our level data, and we'll call this levels, and let's create our method to generate our default level. So for generating our default level, let's get our levels first, and it's going to be a new dictionary. And what we'll do is for each item in our all level list dot levels, we need to set the levels for our item dot level name to item. So it will set up our dictionary, and after that we will create our level data. So generate level data. And here we are not passing any parameters. That means we need to generate our 0th level, and it needs a reference to our current level. So private level data, our current level data, and after that our private void generate level data, and here we'll pass the level. By default it is going to be 0, and if we are passing any of the 1 to 50 then it will change. And let's first get our current level name. So our level naming was level plus, and our stage dot toString plus our level dot toString. And if our level dot contains key, and will pass our current level. So if it contains that key, then we don't need to generate a new level, but if it contains it, then let's create it. And to create that, it should be only possible in the editor. And after creating that, what we'll do is we'll set the levels for our current level name. Mm, 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 Current level. Let's rename this to current level name, and it is going to be equal to a new level, which is our current level data, and we made it capital, so make it small. And after that we need to add it to a level list. So all level list dot add all level list dot levels dot add, and will pass our current level data. And if it does not exist, and if we are inside the editor, then we'll need to create it. And to create it, it's just a scriptable object dot create instance for our level data, and after asset database dot create asset. So it will create an instance, but it is not going to save anywhere. Then we'll need to first create an asset, and we need to save it. So we need to create our current level data at our assets slash common slash prefabs and slash levels, and the name is going to be our current level name, current level name plus, and we need to pass the dot asset, and we need to save this asset. So asset database dot save assets. So it will create a new, and it will save it. And what we need to do is also initialize our current level data. So our current level data dot name is going to be our current level name, and our current level data dot edges is going to be a new list of edge. And after that we need to start uh, editing our current level data, and here we'll pass our generate default, and Okay, so this we can have it initialize in our start methods, or whenever we click simulate we can generate default. Yeah, let's just leave it here. And whenever we click, we are going to set up our dictionary. And also, after all of this has happened, we need to simulate button dot set active to false, so we don't click it again. And that should do the trick. So the main part is this: we created an instance, created an asset, and saved that asset, and then we can directly access it inside our level list. So whenever you click on our button, it should create a new asset, and we already know that assets how it is going to generate. And after all of this has happened, it should not be inside our not. Uh, okay, so hmm, after adding current level data is equals to levels for our current level name. So if it already contains that, then we need to directly get it, else we'll add it to our current level name. Then we'll set its level name and we'll set up its edges. And that should be it. Now let's go inside Unity and let's add the function to the simulate. And yeah, so we'll need to pass the level list, which should be inside our prefabs, and it is inside our level. And our simulate button is going to be our button, and our simulate is going to need a button component. Let's set its color tint to none, and we'll add the function, which is our click simulate function. And now our inside our prefabs and the levels, instead of our default level, we should have a mm, mm, mm. So why didn't it happen? So click simulate and can generate once, generate default, generate level data. So why it didn't work? So let's reset our scene. So let's go to the main menu and again we'll go to our level generator. Let's hit play and inside our common prefabs. Okay, so the levels level 00. So it generated, but the naming is a little bit different. So let's delete this and it should be inside common prefabs, and the path is different and we'll need to set up our path. So assets slash common slash prefabs slash levels, and we need to forward and add, and our current level name was level plus. Okay, so we forgot to add the slash, that's why it added in the wrong path. And now let's go inside Unity and let's try some different value of 1. So it should show us a 5 cross 5 grid, and inside our levels Okay, so there was an issue with our yeah. So the element was added here, but we removed it, so it created a reference exception error. So let's hit simulate, and inside our levels, we should have a level for our stage one, and by default, the zero is the default level, and that's how we create a scriptable objects by scripts. And in the next part, we'll just start with the most dumbest method, which is randomly assigning colors to the whole our grid. And we'll also see how we'll render our grid on the screen. So we have our simulator level generator scene setup. Let's hit play, and the level is generated in our level 0. And what we need to do now is create those levels. So for the starting, we are just going to use a random spawning method where we spawn each of the color, which are two cells on the board, and they are going to spawn randomly. And we are going to have multiple methods, so we'll need to create a interface, and whatever method we are going to use is will call from our level generator function. So whenever our button function is called, which is our generate level, it will call from that interface, and each interface will have different methods, and also for rendering we need to set it up. So let's go inside Visual Studio, and let's first set up our node rendering. So on node rendering is going to have two functions, and the first function, it is going to be not two functions, just one function, so public void, and it is going to be for rendering the grid. And inside our render grid, we are going to pass just one parameter, which is a dictionary of v2int to an integer, and we'll call this grid. So each position in the grid is going to have some color, and if it is empty, it is going to have -1. And we'll cache a couple of things, which is going to be a current color, and int our number of connected nodes. And we also need to show up our edges. And what we'll do is, for each of our item in our node grid, uh, we will first initialize it. So item.value.init. So it will reset it. And what we'll do is get our current color, which is going to be inside our grid, item.key. And our number of connected nodes is going to be 0. And first we'll render all of our edges. So to check our edges, we will first check if our current color is not equal to -1. So if it is -1, that means it is empty. Then we'll go inside our direction in our directions, and we'll need to create our directions. So let's create those directions. So private list of v2int, and we'll call this directions, and it is going to be new list, and we'll need to initialize it. So it is going to have the up, the down, the left, and our right. And for each of the direction, we'll check if our node grid has a valid node there, and that node is same color. So first we need to check if our grid dot contains key and it is going to be our item dot key plus our direction. And after it contains, we need to check if our that position is equal to our current color, and if it is, that means we need to update our color. And what we'll do is item dot value dot set edge, and then we'll pass our current color, and finally we'll pass our direction. So it will create an edge there, and we need to increase the number of connected nodes. And if all of this is not happening and our number of connected nodes is 0, so after we have checked all of our directions and still our number of connected nodes is less than 1, that means we are going to set the edge, will pass the current color, but the direction is going to be 0, so it will convert this to a point. And after we have done our node rendering, it is going to be set as a public method, and our level size also needs to be public. Then spawn nodes button function will need to create a new script, and it should be for including all of our methods. So we should be finished with our node rendering, and here we are going to create a serialized field, and it is going to be private generate method, and we'll call this current method. And it is going to be an interface which is going to have a public void, and it is going to have a generate function, and we have our generate method here, and we'll need to create our first script which is going to be spawning randomly. And what we'll do is after all of this is finished, we'll use our current method, uh, mm, mm, mm. So our current method, and it is an interface, so it should have a generate function, and we'll need to create this interface as a script, and that is going to be our first script, and we'll collapse everything. So that is our start method and our interface. So let's go inside Visual Studio, and we'll need to create our random spawning script, which is a generate method, and we'll open that script inside our Visual Studio. So it will open up our script, and it is going to have a interface, and inherit the interface, which is our generate method, and public void generate, and our private, and we need a reference to our level generator, and we'll call this instance, that is only going to be 1, and in our start we'll set our instance to this, not this, get component, and our level generator. And we will need a grid, so let's pass create a dictionary which goes from vector to integers, and it's going to be our current grid, and we'll need to set up our current grid inside our start method, and we need to reset it, which is going to be a reset grid function. So let's create our private void reset grid function, and in our reset grid function what we are going to do is we'll first clear it, and for int I is equals to 0, I less than instance dot level size, and code snippet for reverse for loop, and for j less than 0, instance dot level size, we'll set our current grids new I and j to be equal to -1, so everything is empty. And inside our generate method we are going to start a coroutine which is going to spawn random, and we'll create the coroutine here. So private enumerator spawn random, and it is going to bool and is spawning is equals to true, and while is spawning we are going to first reset the grid, and we'll update the grid inside the instance which is going to be render grid for the current grid, and we'll repeat, and we'll wait for a new wait for seconds, and let's pass 0.16f as the parameter. After we reset the grid we need to set up the starting nodes, and let's call this let's start nodes, and we'll create that method here. So first let's get our direction, so it should be inside our node generator, and these are our directions, and inside our private void set start nodes we are going to start our nodes. So our start nodes is going to have a couple of parameters. The first is going to not parameters, what do you call it as variables. So first we are going to need a vector to list of integer, so which is our spawn list, and it is going to be from our current grid dot keys dot to list. So this is our spawning list, and we need to get our maximum amount of colors, which should be random dot range from 0 till casted to an integer, mathf dot square root, and here we are going to pass our instance dot level size, and we'll divide this by 2, and we need to add our level size. So our level size is 3, which should be, then it will get us somewhat around like 3 colors, and again we'll cache a couple of parameters, so random first id and random second id, and after that we do int our first spawn pose and our second spawn pose. So how many colors we need to set? So let's create an or loop, and the maximum amount is going to be the maximum of colors. And what we'll do is bool will repeat list is going to be true, and while we are repeating the list, we'll first set our random first id random dot range from 0 till our spawn list dot count, because we need to get our and again it is going to be random dot range from 0 till spawn list dot count, and these are going to be our two IDs. And now what we need to do is we need to check if our random first ID is equals to random second ID. Then we'll continue the loop again, and our will repeat list is already true. This loop will continue. Then we'll get our first spawn position, which should be random list. We'll pass the ID from the spawn list. Then we'll get the second spawn position, and it is from our spawn list random second ID. And what we need to do is will repeat list is going to be false, and we'll check each of our directions. So for each direction in our directions, if our first spawn position minus our second spawn position is equal to direction, that means we are both are neighbors, and will repeat list is going to be true. So it will be set to true, and the list will repeat again. And if the list is going to repeat, then we are not going to do anything, and let's set the continue. But if it is not going to repeat, then at the end okay, we'll set our current grid, and this is going to be our first spawn position to be equal to I, current grid our second spawn position to be equal to our I. Current grid first spawn position. Okay, so this is unassigned, and spawn list dot remove first spawn position, and our spawn list dot remove second spawn position. So both are unassigned. We'll need to let's set it to hmm hmm hmm. So if it is not continuing, then we'll just put it here, and the loop will not continue, and that will be executed, or the loop will just finish here. And that should be it for our spawning. Now let's go inside Unity, and for our level generator we'll need a random spawning script, and our random spawning is going to be assigned, which should be current data. So did we create a serialized field inside our level generator? So let's go inside button function, serialized field. So we cannot get it. So we'll need to get the current method, and instead of current method, so let's go inside Visual Studio. What we'll do is we'll directly get the component, and which is going to a generate method, and we can directly use the generate. We don't need to initialize it, but we'll need to set in our just add the script, and it should initialize, and let's see what is happening. And it showed us an error, and that was because we are passing -1 here, and -1 should not be passed, and we need to go inside Visual Studio and our random spawning. We are rendering the grid, so that should be inside the node renderer level generator, and inside our node rendering, then current color is not equal to -1. So everything is working, everything should work perfectly fine. Okay, I got it. So that was the issue because our node does not have any colors. My bad. So let's add our first color. Let's also add our second color, and let's just add all of our colors. Third, fourth, fifth, and sixth, seventh, eighth, nine, 10, and these are all of our colors, and maybe now there won't be any errors, and let's see what happens. So as you can see, it okay, so it is showing up, and there was some error, and it should be perfectly fine. So let's see what we can do with the next method. And my PC has crashed. So we'll check how this method works, and we'll fix it up in the next part. We created a method for spawning our starting and the ending nodes for each of the grid, and it was working perfectly fine. And let's add the script, which is our random spawning, and it is going to spawn our as you can see, it is spawning correctly. In the previous part, there were some issues where somehow, as you can see, these are the empty 3 neighbors, and if our final empty cells are this 4, then it will stuck in an infinite loop. So that's what I fixed it, and let's see how I fix that. So let's go inside our random spawner, and let's go inside Visual Studio. So previous it was we were directly setting up the start nodes, and if it returns true, then uh, that means the start node is valid, then it will directly render the grid. But if it returns false, then this loop is going to run again, then our start node is invalid. And what we did was checking, instead of we had a while loop which was running, which was causing the error, but the only while loop we are having here right now is for checking if 2 positions are equal. So we are always going to have greater than 2 positions, so this both will never be equal, and everything else is same, and we return the false, and then we return the true. And if it returns false, that means our one of the direction matched, that means our node is invalid. Then it will reset the grid, and it will call the function again, and if it returns true, then we would have for all of the colors we would have added two positions, which are the starting and the ending nodes. So that was for the previous fix. Now let's go inside Unity, and we are going to create our current script, which is all paths, all neighbors path. Yeah, so we'll call this all neighbors, and we'll need to create the script, and it's almost a pretty big script. So let's create a CHash script, and it is going to call all of the neighbors. NEIGHPOURS. So it should be open inside our Visual Studio, and as you can see, don't show this. So it's an empty script right now, and it is going to be similar to a random spawning, which is going to implement our generate method interface, and we'll need to create that function. So let's implement the interface, and we'll see what we need to do. So our generate method is going to list all of our grids which were created, so we can see it in the increasing order, and it is going to show how many lists we have created. So we'll need a tmp text, and it is going to be our timer text, and final one, which is going to be our grid count text, and we are going to have a private list, and it is going to be of the type grid data, which we are going to create. So let's create that. So public class grid data, and our grid data is going to have the constructor function, and let's do that. And member modifier must precede. So okay, yeah, here grid data, and our data is going to be our checking grids. And here we are going to store all of our grids, and we are going to have a reference to a level generator, and we'll call this instance, and a private boolean for if we are currently creating, and we are also going to have a serialized field for our private float for the speed multiplier, and a serialized field for our private float of speed. So how much delay we want when each of our uh, grid is showing. So we'll use yield return new wait for seconds, and we'll pass the speed. And inside our start function, we need to set our checking grid to be new list, and our instance is going to be equal to get component, and we'll get the level generator component, and is creating will set to true. And what we'll do inside generate is we'll start the coroutine, and our coroutine is going to be our generate paths, and we'll need to create this coroutine. So let's create our enumerator, generate paths coroutine, and at the end let's use a yield return. So what our generate paths is going to do is first we'll set up our list. So level size divided by 2, and we need to set less than equal to, and after that we are going to have one more loop which is going to run from j till I. So our starting positions are going to be the corner, cause that's some symmetry for our grid, and we'll create a new grid data, and we'll call this temporary grid, and it is going to be our new grid data, and we'll add it to our checking grids. And after we add them, we'll need to solve all of our paths. So we'll pass our solve paths, and it's going to be a coroutine. So let's use start coroutine, and we'll pass our solve paths method, and let's create that method. So private enumerator and solve paths, and let's use a yield return new wait for seconds of speed. And after we have solved our paths, our checking grid is going to have populated all the grids. So we'll render that grid, and we'll render each of the grid by index. So our count is 0, and while we are creating, we need to render our grid. So first we will check if our count is equals to our checking grid dot count, then we don't need to do anything. So we'll yield break. But if it is not, then we need to render our grid, which is going to call from our instance, which is the level generator, and we'll pass the render grid function, and it is going to be from the checking grid, and we'll pass our count, and our grid data is going to have a public dictionary which goes from v2 int to an integer, and we'll have it as grid, and we'll pass our grid, and let's use underscore so we can rename it. So it is going to render our grid, and after our grid is rendered, we'll increase the count, and we also need to show our timer text. So our timer text is going to be equal to how much is it going to be, count dot toString, and our grid count text is going to be checking grid dot count dot toString. So our grid count is going to get us the total number of paths we have solved, and our timer text will show whichever path we are solving currently right now. And after that, we'll yield return new wait for seconds of the speed. So that's it we are going to do in our rendering function. And the next we need to do is solve all the paths. So let's create a private static list of, doesn't matter if it is static or not. So it is going to be list of integers, and these are going to be our direction checks. And inside our direction checks, we are going to create a new list, and here we are going to have up, down, the left, and our right. So that variable is going to be needed, and after that, to solve all of our paths, we are going to need to set up our grid data. So again, we'll need to copy our list, uh, and this one will make it static so it doesn't show any errors. So this is going to be static. We just need one instance of it. And what our grid data parameter is going to pass is the I and the j, or we can directly pass the vector2 int. Doesn't just I'll just copy whatever what was modifications will produce more bugs. And what we'll do is int I is equals to 0, int I less than level size, and for int b is equals to 0, I less than level size, our grid for our new vector2 integer for our a and b is going to be -1. And we need to create our grid first, so grid is going to be new dictionary, and after that we need to create a few more variables. So one of the variable is going to be public bool is solved, and this is just going to store if we want to create more neighbors for this grid. And next one is going to be public vector2 integer for our current position, so what neighbors we want to create, and a public integer for our color ID. So let's first set our isSort to be false. Then we'll set our current pose to be ij. And after that, we'll set our color ID to be equal to 0. And we need to set our first color, which should be for the grid for our current pose, to be equal to our color ID. So current pose is equals to our color ID, and that should be for our default constructor. And after we have this constructor, we need to create one more constructor which is going to uh, get more parameters, in which we are going to get the coordinates and also the past color and a grid data, for which we'll need to create the copy, and we'll call this grid copy. And what is going to do is first set up our grid, and for each of our element in our grid copy dot grid, we will copy it inside our current grid. So our grid for the item is grid for the item dot key is going to equal to item dot value. So it is getting copied in our current grid. And after that is happened, we'll set our current pose to be our new vector2 of I and j. Our color ID is going to be equal to our past color ID, and our grid for our current position is going to be equal to our color ID, and isSolved is going to be equal to false. So we copied everything, and we created new color, so it is going to be pretty similar. And after, we are going to have a couple of methods which is going to return. So first one is going to be is inside grid, and here we are going to pass a v2 int of our position. So how we are going to know if anything is inside the grid? So if the grid that contains keys, so if the key is contained, that means it is a valid position. And we all only created the positions which were valid, which is inside the square, so it will return us that. And also we need to check if our grid is complete, and for the completion of the grid, let's return true. But if any of our condition doesn't match, so the first condition is going to be uh, for item in grid, if our item dot value is equals to -1, then we return false. Cause if anything is empty, then we are going to return false. And for int I is equals to 0, I less than our color ID, so I less than equal to color ID, so it is going to start from 0 and maximum it is going to go from our color ID, and we'll create a result. So int result is equals to 0, and for each item in our grid, if our item dot value is equals to I, which is the current color we are checking, will increase the result by 1. And after we have checked everything, if our result is less than 3, then we are going to return false. But if it is not, then we have checked that color, then we'll set the result to 0. Okay, so it is already set at the start. And that's how we are going to check if our grid is complete. So all the grid colors should have a length greater than 3, and none of the positions should be empty. And after that we are going to have 1 2 3. Okay, so 3 more functions, and the first function is going to check if we are not a neighbor, and it will return true if we are a neighbor, and we need to pass our position, and will return false at the end. But if none of our condition matches, then we'll return true. Okay, so it is going to return true. So when our position is going to be neighbor, so we are going to check our position for only our current color. So for each item in our grid, and if our item dot value is equals to our color ID, and our item dot key is not equal to our current position, cause we are going to pass this value in all of its neighbors, so our current position is always going to be a neighbor. So we need to check that, and what we'll do is for each of our direction in our direction checks, if our position minus our item dot key is equals to our direction, then we are going to return false. That means is not neighbor is false. That means it is a neighbor, and this loop will end. So uh, is not neighbor is going to return true when it is not in any of the directions, and if it is any of the directions, then it will return false. And finally we are going to have two more functions. So the first one is going to return all of our empty positions, so we'll create a list of v2 int, and we'll call this empty position, and let's create a new list, and it's going to be of type v2 int, and we'll call this result, and it's going to be a new list. And what we'll do is for each item in our grid, if our item dot value is equals to -1, then we'll add it to our result. So result dot add item dot key, and we'll return our result. So it will get us all of our empty positions, and finally we are going to have a public int to get our current flow's length. And how we are going to calculate it is for each of our item in our grid, if our item dot value is going to be equal to our color ID, then we are going to int result is equals to 0, then we'll increase the result, and at the end we'll return the result. So I created all the methods first so it doesn't have any error, and we are going to use these methods to solve all of our paths. So we already have our new grid data. We need to pass ij and our level size, which is going to be our instance dot level size, and it will create our checking grid, and it is going to have 3 starting positions. And we have not used any of the functions till now, so let's see what our function is doing. And inside our level generator, instead of the random spawning, we'll remove that and we'll add all neighbors, and it is going to have a speed multiplier of 10 and speed of 0.5. And we'll need to add our counter to our grid count and our solutions to our grid count and our counter to our timer. And let's see, for our -1 we are just going to go for the -1 level because the complexity is going to increase for the next level. And let's hit play, and it should have 3 solutions. So as you can see, for the starting grid we created these 3 solutions, and now what we need to do is expand those 3 solutions, and again we are going to expand and till all of our solutions are reached, and we are going to expand. So overall there is just 9 grids, and the total number of solutions I already created, so that doesn't not the solution. So what we are checking, it is around 3000 only, and for our 4x4 grid it almost like ran up to, I don't know, for around 5 million solutions. The grid was still running and the coroutine was not too efficient. So this solution is going to work for only 3x3, and we are just going to visualize how it's going to work. So what our solve path is going to do is we are going to use a while loop to check if all of our checking grids are solved. So let's create our bool can solve to be true, and our integer iterations per frame is going to be equal to our integer, and will multiply by the speed and divide by our speed. So here our speed is time, so that's why we are dividing it, and we'll create one more integer for our current iter, and we'll start at 0. And while we can solve, we are going to solve. So the first thing we are going to need is a list of grid data, and we'll call this result grid datas, and it's going to be a new list. And after that, what we are going to do is copy each of our item in our checking grid, and if our item is solved, then we are going to not copy, but if it is solved, then we'll copy inside our result grid data dot item, and if it is not solved, then only we are going to copy it. And if there are no items inside our result grid data, so if our result grid data dot count is equals to 0, then what we are going to do is will yield break, and can solve is going to be equal to false. But now we can solve, then what we'll do is for each of our item in our result grid data, we'll first get its index, which should be result grid not checking grid dot index of, and we'll pass our item, and we'll set the insert index. So we are going to insert inside this grid, and we'll start from 1. So if our position index is 0, then we need to insert our grid at 1. So whatever is at the 1 will be positioned at 2, and it will insert our current to be at 1. And what we'll do is what we need to insert. So first we are going to insert our direction checks. So we have our direction, then we'll create a vector to integer for our checking direction, and our checking direction is going to be equal to item dot our current pos plus our direction. And what we need to first check, if item dot is inside grid, and we'll pass our checking direction, and our item dot grid at our checking direction, so it should be empty, so it should be -1. And finally our item dot is not neighbor, and we need to pass our checking direction. So we didn't update the current position, but for our current position, uh, except uh, it is the neighbor of our current position, but we have not updated the current position. So what it's going to check is whatever color it has at the current position, find all the similar colors inside the grid, and they should not be neighbor for our current checking direction. And our current position is already invalid, so we already removed that checking inside our not neighbor, so it should not be equal to current position. So it will check for all of the other positions for the same color ID, and if it does not match, then what we are going to do is where did we get, so if it is not neighbor, then we need to add it to our checking grid. So checking grid dot add, not add, we are going to insert it, and where we are going to insert is position index plus our insert index, comma, and what we are going to insert is our new grid data, and here we are going to pass our checking direction dot x, checking direction dot y, and we have created a new color, so we need to pass the color ID, which should be from the item dot color ID, and we'll increase it by 1. And finally we need to pass our item dot just item, so it will create a copy and insert that. We need to increase the insert index, and for each of the directions, if it matches, then it is going to insert it. Now there are going to be other positions, which is going to be for each of our empty pose inside uh, item dot empty position. So it is going to return a list, and what we need to do is add all of those items. And here we don't need to add one, because that was just a valid position. But inside our empty positions, we are directly going to add if our item dot flow length is greater than 2, then we can create new positions. And similarly, we'll pass both of them here. And instead of checking direction, we'll pass our empty pose. And the color ID we are going to increase by 1. So it should create that for us. And after that, we are while cancel result grid, and this while loop is going to, so these are the two for each loops, and this is the result grid data. And at the end, where is our result grid? So when our item is solved, so after insert index 2, we need to set this item to be solved. So item dot is solved is going to be true. So it does not create its neighbors again. And after that, we'll increase the current frame, current iter by 1. And if our current iter is greater than our, what did we name it? Number of iterations per frame, then we'll set our current frame to be 0 and we'll wait. So yield return new, wait for seconds, and we are going to wait for iter for frame. Not iter for frame, we are going to wait for the speed. And that should be it. And maybe it won't show much errors. Let's go inside Unity and let's see if we have to do anything. So the current speed is a little bit small, so I already know that there are 3000 solutions and we need to finish it in 30 seconds. So let's pass 0.1 and let's set the speed to be 100, and let's see if it shows the number of solutions. So as you can see, it is already showing up all our solutions and it passed perfectly. But there's one problem. So the number of solutions we found were only 3000 and there are too many duplicate solutions. So we are just going through everything, and this was we are just going to iterate it again, and for each of the level we'll make our method more efficient in memory and time. And uh, after almost 6 cross 6 or 7 cross 7, we are going to run out of, there'll be too much memory, then we'll need to do the randomized checking, and there will be so much to do. So it is running perfectly fine, and as you can see, there are so many duplicates which could have been solved if we didn't do that. And we could have some checked method check which just generates neighbors for only the valid one. So, and also because of the symmetry, we are finding multiple solutions. And let's go inside our Visual Studio and let's create one more boolean. So serialized field private bool, and it is going to be show only result. And let's go inside our rendering grid, and we need to check if our checking grid at our count dot is complete. So if it is complete, then we don't need to do anything. But if it is not complete, then we'll pass it to while loop. We'll increase the count, and we can copy this here, and that should show us only the valid solutions. And we need to set up our show only result, and we need to pass our show only result. And so if it is turned on, then it is only going to show our valid result. So I just passed the show only result. So just passed it here, and let's go inside Visual Studio, and let's see how many valid solutions it is going to pass. So let's by default, if it is turned off, it is going to show us all of the solutions. But if we turn it on, then it will only show the complete solutions. So checking grid dot count dot is grid complete, count plus plus. So maybe there was some issue. So let's hit play. And while we are showing only result, and so let's see what is happening. And let's hit play, and let's see if we are going to get any of the results. So it is not showing up anything. So let's see where we did wrong. So first thing we are going to do is comment this out so we can debug it. And again, it took more than 40 minutes. So uh, the the previous method, this is the first method, the previous method didn't even check. So it is working perfectly fine, but whatever solutions we are getting, we need to check that. And what we need to do is update. So if our checking grid dot count is grid complete, then we'll update, but we need to do that if it is not complete. So it is going to be a while loop, and if our count is going to be checking grids dot count, then it should work. So what we did was uncomment it, and let's see why is it not working. So let's hit play, and it is again not working. We are increasing the count. The count was started at 0, and it should not be complete. Then we need to go inside the next. I think it may be because our solve paths. Mm, yeah, it may be issue with our solve paths, because we are just solving randomly. So let's use 10,000, and let's see what it's going to show us. So that was because our checking grid was already 0, so initialization some error. And as you can see, it is showing up all of our paths, but most of them are similar. And that's what would happen if we just show some random simulations. And let's hit play again, and let's see our simulation at last. So these are all the final levels we got for 3x3, but most of them are similar. And this is what I reached after fiddling around for 20 to 25 days. And I already created some solutions for more of the difficult parts, but they are not too friendly. Some of them just crashes somewhere, so I'll need to optimize that. And that was it for the starting part. And if you want, you can like directly hand code the solutions, not hand code, just type it inside our level list. They are available online, and I think if you just take a screenshot and automatically like do something, then there will be uh, more better solution. But coding this is going to be a little bit difficult, so we created a 3 cross 3 grid method, and after to convert it to 4 cross 4, it is going to be so much difficult. And the problem is the first valid solution we are finding is too far. And let me show you what is going to happen, and this video will end with a crash. So inside our solve paths, it is running perfectly fine. And what we need to do is add our condition here. So it is going to be what was the condition? Show only result, and where is our and? So it is going to only show the result when it is finished. So let's go inside Unity and let's check if it is working. So if we turn it on, then it should show us all the results. But if we turn it off, then it should not show it will show all of the solutions. And let's see what will happen if we just increase the grid count stage by one. So this is a 4 cross 4 grid, and what is going to happen is our overall grid count is going to grow much large. So the maximum is like 4 to the power 9. So that is some different complexity. I don't know how it is calculated, but 4 to the power 9 is almost like 1 billion multiplied by 1 billion, and nobody has that much amount of memory. And we'll need to optimize our previous solution, check, and optimize at the start and don't need duplicates. So if it simulate, as you can see, it grew at the rate of 40,000 on the first, and it is going to grow pretty much large, so much large. So till we reach the fourth step, we had like 100,000 grids, and it is going to slow us the PC. So I just stopped it right now because I don't want to crash my PC. And in the next section, we'll try all the different methods. I don't know what methods are there, and it is almost a pretty big topic. So see you in the next part. And if you watch till now, you can pretty much like create the 5 cross 5 and copy from the online. So the solutions are available. And thank you guys for watching.